So in this video, we're going to do several practice problems working with equations of lines. In the previous video, we derived what's called the point-slope form of the equation of a line. Here it is again. In this equation, y minus y sub 0 equals m times x minus x sub 0. M is always going to be the slope, which is change in y over change in x. x0, y0 are going to be the coordinates of some point you know to be on the line. And x and y are going to remain as variables in the equation. Let's do an example so you can see what sort of problems you might see involving this. So we have here, determine a point-slope equation of the line that passes through these 2 points, 1 minus 3 and 4, 1. We could draw a sketch of the line. We got 1 minus 3 is over here someplace. 4, 1 is over here someplace. And so it's going to look something like that. This is not necessarily drawn to scale, but at least I can tell it should have positive slope. It looks like it's sloping upwards. So how do we write down a point slope equation for the line that goes through these 2 points? The first thing we always do, and we always need this when we're getting equations of lines, is we need to compute the slope. Remember, slope is change in y over change in x. So I have to choose one of these as my start point and one of these as my end point. So I'll make this my start, this my end. So remember, the way we get changes is by subtracting coordinates, end minus start. So for my slope, change in y, remember y is on top, is 1 minus negative 3, end minus start. Change in x, 4 minus 1. So this is 1 plus 3 over 4 minus 1. So this is 4 over 3. So that's the slope of this line, and it is a positive value, as we guessed from looking at the picture over here. So when I look back at my point slope form, I know that m is going to be replaced with 4/3. X and y in my final answer will remain as variables. So I'm going to leave these as variables. And the x0 and the y0 are replaced with any point that we know is on the line. We know either one of these is on the line, so we could plug in either this point or this point's coordinates for x sub 0 and y sub 0, and that will give us a correct answer to the question. In other words, there's more than one correct answer for a point slope equation like this. So if I chose this point, then I would have, then this would be x0 and this would be y0. So I would have x minus 1, because x0 would be 1. And then I would have y minus y0, which is y minus negative 3. And I'm never going to write y minus negative 3. I will immediately change it to y plus 3. And this is a correct answer. You could also choose the other point. So if I chose this point to be x0, y0, then when I do x minus x0, it would be x minus 4. And when I do y minus y0, it would be y minus 1. This is also a correct answer. You don't need to write both of these down. Either this or this is correct. We just want one point slope equation. I was just demonstrating the 2 possible answers you could get from this question easily. What if we start with the equation? Let's see, sketch the line with this equation. First I need to recognize, this is point slope form. It's got the y minus y0 equals m x minus x0. And then I have to extract from the equation the m and the x0 and the y0. The m is straightforward. M is what's multiplying this x minus 3 term here. So the slope is 2. You have to be careful with x0 and y0 though. X0 here is straightforward. In the form, it's x minus x0. And here I see x minus 3. So if I ask, what would I plug in here to get this? Well, x0 would have to be 3. But y0, notice in the form, it's y minus y0. In the equation that I'm given, it's y plus 2. So the question is to say, okay, well, what would I plug in here to change this into this? And I would have to have y0 be a negative. So y0 would be minus 2. And if you look at the equation that we started with and the coordinates of the point that end up being on the line, you'll see that there's this sign change that occurs. That's because the form has minuses in it. So when we go from here to here, we get sign changes. You can see here we have x minus 3, but plus 3 is the x coordinate of a point on the line. And then we have y plus 2, but minus 2 is the y coordinate of a point that we know is on the line. So just be careful with that. So, how do we draw the line given this information? Well, we start with the point that we know is on the line. We know that 3 minus 2 is a point that's on the line. And then we write this slope as change in y over change in x, and we use it to create more points that are on the line. Now this is not a fraction, and so I'm going to make it be over 1. So this is 2 over 1. So this tells me, starting from here, to get more points on the line, I have to change y by plus 2, and when I do so, x has to change by 1. So this is up 2, this is right 1. So starting here, I'm going to go change in y of 2, change in x of 1. This is why, and of course this repeats over and over again to create more points on the line. This is why sometimes you see slope referred to as rise over run, because it's go up a certain amount and then run to the right a certain amount. It has that nice alliteration. And so by doing lots of this, we can create lots and lots of points on the line. We keep going up 2 over 1, up 2 over 1, up 2 right 1, up 2 right 1, up 2 right 1, and all these points are on the line. So the line looks something like that. Another thing that you'll see on the homework is the more familiar from algebra slope-intercept form. This is y equals mx plus b, and everybody seems to remember this from Algebra 1 and Algebra 2 because it's catchy. M, of course, is still the slope. This plus b is the y-coordinate of the y-intercept of the line. So it's y where the line crosses the y-axis. This has the advantage of being a simple form to remember, and it also has the advantage of being unique. The line only has one slope-intercept equation. The disadvantage is that you have to work with this point, unlike the previous form where it could be any point on the line. We're going to do more with this in the next lesson, but let me show you the kind of thing we're going to see on this homework. And all you're going to see on this homework is asking you to sketch lines that are in slope-intercept form. So here's the slope-intercept form. Let's match it up with the form here. So m here must be this minus 1, and b is 5. So remember, b is the y-coordinate of where the line hits the y-axis. That's what's known as the y-intercept. Once you know this information, this proceeds very much like the previous example. I start with the point that I know is on the line. Since the y-intercept is 5, that point must be on the line. That's 0, 5 up here. And then the slope I'll write as a fraction. Since it's just minus 1, I'll put it over 1. And this tells me I have to go down 1 and then right 1 to get more points on the line starting from this one. So with the slope of minus 1, I go down 1, right 1, down 1, right 1, and if I do this over and over again, I can create lots of points that must be on this line And so this line looks something like this. We'll see more with point slope form in the next lessons. A couple more quick examples. There's some problems on the homework that ask you to work with parallel lines. And I'll ask you on the homework to explain why parallel lines have equal slope. There's a diagram on the homework that I'll ask you to explain in a sentence or two why that's the case. Here I'm just going to show an example of how we use that fact. So we're going to determine an equation of a line that's parallel to this line, and that goes through this point. And I'm going to be using point slope form here. That's this one. Because I want you to get comfortable with this and not only be comfortable with y equals mx plus b as the equation of a line. So I need to determine an equation of a line. I'm going to write it in point slope form. So if you recall, that means I need to figure out what the slope is, and I need to figure out some point that's on the line. Well, I've already given a point on the line. Determine an equation line parallel to this, and that passes through this point. So this is going to be my x0 and my y0 to plug in here. I need the slope. Well, the line that I want is parallel to this line. And the fact that I'm going to ask you to explain on the homework is why parallel lines have equal slope. We're just going to put this to work now. If I look at this equation, this is also in point slope form. And so I can read off the slope. I can also read off the point that this line passes through, but that's irrelevant here. What I need is the slope. The slope is negative 3/5. It's this number multiplying the x plus 7, because the line that I want is parallel to this one, so it has to have the same slope. So the line that I'm looking for has the same slope as this one. And then I need to plug in my x sub 0 and my y sub 0, some point that's on the line. So x sub 0 is 1, because this point's on the line, so I can put that in there. Y sub 0 is minus 1, so this will become y plus 1. And that's it. Finally, last example. Perpendicular lines. So again, on the homework, I'll ask you to explain this fact. Here we're just going to use it in an example problem. The fact is perpendicular lines have what are called negative reciprocal slopes. Negative means the slopes have opposite signs, and reciprocal means you take the reciprocal of the number part of the slope. You'll explain why that's the case on the homework. You can see they have to have opposite signs, because if two lines are perpendicular, one's going to be sloping up, and the other's going to be sloping down, so they will have at least different signs. But why they're reciprocals is something that I'll ask you to explore on the homework. Let's just use this fact that perpendicular lines have negative reciprocal slopes to answer a question about perpendicular lines. Determine an equation of a line that is perpendicular to this line, y equals minus 3x plus 5, and that passes through this point. So again, I'm going to be sticking with point slope form here for my answer. Here's a point that I know is on the line. It passes through this point. So that means I can do negative 5 for x sub 0, which will give me x plus 5. And I can do negative 2 for y sub 0, so I'll get y minus negative 2, or y plus 2. So the last thing I need to figure out is, well, what is the slope? If I look at this equation, determine the equation of the line that is perpendicular to this line. Well, I know that lines have negative reciprocal slopes, and I recognize this as slope-intercept form, and I can pick off the slope right here. Here's the slope. It's the value multiplying the x. Negative 3. So that is the slope of this line. So the line that is perpendicular to it will have negative reciprocal slope. So we're going to need to change the sign of this and do the reciprocal. Since this is not a fraction, I'll write it as over 1. So it's negative 3 over 1. So the negative reciprocal, I change the sign to plus, and I take the reciprocal of this fraction. So this is the slope of a line perpendicular to this one. And that's the value that's going to go in my equation here, positive 1/3. And this is an equation of the line that satisfies these conditions.